All right. So the speaker is Mark Smith from Belfast, and he's a developer at nChain and a software engineer with about 12 years experience, and started writing Go in 2016. Never looked back since. Currently working for nChain, building a blockchain as a service platform on the BSV chain, as well as contributing to open source Bitcoin libraries at github.com libsv. GitHub can be found at GitHub, and very occasionally gets time to build stuff around family, hobbies, and life. So yeah, please welcome him, and we're happy to listen to your talk, Mark.
Cool. Thanks a lot for the introduction, and thanks a lot for having me as well. I guess first meetup I've done since 2019, so I might be a bit rusty, and we'll see how this goes. If I speak too quickly or whatever, just let me know. I tend to, and if I start freaking out, getting nervous, it's just start rambling on like I'm doing now. But yeah, no, thanks a lot. So yeah, I say my name's Mark, software engineer from Northern Ireland in the UK. Will not mention Brexit, and currently work for nChain, as mentioned. Yeah, working on Go and the Go team, building platform services. It's basically there's blockchain, there's our platform services there. Gives a whole bunch of functionality around like funding management, key management, all that sort of stuff. And what we build is a platform called Kensai, which is basically used for businesses to stream their data through and have it end up in the blockchain stored so they can prove their data exists at a certain state at a certain time. As well as that, as you mentioned, I have open source projects at libsv, which myself, Jad, who's on the call, and Tiernan as well, also work on, and a bunch of others. And I have my own repo on the Flying Coder on GitHub as well, where you can see me occasionally playing with bits and pieces as I get a chance to. So yeah, let's get started. This talk is on automating boring stuff with Go. And oh, where's my thing? There we go. So yeah, cool. So this is the agenda today. So we're going to be using generators to automate boring stuff like boilerplate and test generation and things like that. We're going to go over what a generator is, some examples of generators, the Go Generate tool. We're going to build a generator, and then we're going to also build an API generator as well. I'm not going to write all this code straight away. This is all the code's already written. We'll just look at stuff and step through it, so just wouldn't have time to sit and code all that sort of stuff. So let's get going. So we'll start off with a nice quote from Rob Pike. I have invoked Rob Pike, and it says, "A property of universal computation, Turing completeness, is that a computer program can write a computer program." And that was from the first line of the blog that announced Go Generate back in 2014. So we're going to explore how Go can actually make this true for us using Go Generator. So first of all, what is a code generator? It's very simply something which can create working code. Now, the key thing there is working code. We might produce code that doesn't work, but we're still technically a code generator. So one of the most common code generators is all of us. I mean, we're on a Go meetup, so I assume we've all written code of some shape or form, or want to write code in some shape or form. And people are very much the original code generators, really, because we're pretty creative, right? We can come up with problems and come up with novel ways of solving those problems. But we do kind of suck at doing like repetitive, boring tasks. Like if I have to like do the same thing over and over again, I will mess it up because I'll get bored and zone out. So if we're really creative, I can do some really cool stuff. Like we invented Go, because there was a need there for system programming language. It was easy to pick up. So yeah, we're very good at that sort of stuff, but we kind of suck at boring, repetitive tasks. The other type of code generator is machines. So machines are great code generators, but they do lack creativity to be able to understand and analyze a problem. And I say yet in this because as AI gets more and more intelligent, and see like likes of Git Copilot and stuff like that there, which you can write you code. But at the minute, needs a lot of a human input there to help guide it. They really excel at executing the same things over and over again flawlessly. So we want to put them to work. Basically, we want to take that repetitive stuff, which we suck at as human code generators, and get machines to generate the code for us. So let's just explore sort of a few components that make up a generator. There's always, you're going to have some sort of input for a generator. So it could be, flag arguments on a command line, could be environment variables, config files, remote configuration. You might not have any input, just generate something. Or it could be like, technical specs or something like that, if it's a human generator. I'll say examples of generators are people or machines. And we can use a language to then create code. And really all the code really is, it's just a string really. At the end of the day, on your screen. So we take those inputs, a machine or a person generates some code and outputs it, and there we go. That's all a code generator is. So why would we want to automate code generation? So we have a consistent output every time. So if your generator is well written, each time it's ran, it's like having your best developer writing all your boilerplate code in fractions of a second. You can encode your company policies, your best practices, everything. And a really good example of this is the Stringer Go Generate tool. Most people have probably used the Stringer tool. It allows you to generate string representations of a constant list that uses IOTAs, or is that like enums? And what it actually produces is really efficient, highly optimized code that I certainly couldn't write from scratch, but somebody really smart wrote that code, and every time you run that, execute that generator, you get that same brilliant code over and over and over again without you having to write it, because it's really boring. Like if you add a new enum, for example, you don't have to go and write and add and modify your code, just run a generator and off you go. So it gives you huge time savings. Think like also auto like generating like a full API or service instead of manually bootstrapping it. Like there's so much bootstrap code goes in whenever you're creating the APIs and things. And as I mentioned, you can encode your company best practices and patterns. You might want to, like, everything has to have a certain format, have these particular arguments, this particular signature, everything has to be commented. We'll want to do this, that, and the other. That could be all codified in your generator. And what it frees you up as a developer to do is work on interest and stuff. Generate out all the boilerplates code and regenerate it over and over again, and spend time working on the interest and logic and the interest and libraries and things like that around the boring stuff. It's all about automating boring stuff away from you. So we quick recap before we go on to the next section. Just code generators produce working code. People are very creative but very easily bored code generators. Machines are dumb, but they can carry out the same task over and over again really effectively. All generators have some sort of input and output, and that's a huge time saver, and they ensure consistency in your code. So we're going to take a quick look at some existing generators, and then take a deeper dive into one to have a look at how generating code, how we actually go about generating code, and things like that in a bit more depth. So in Go, like you might have came across some of these. Most people have came across a Stringer. If you haven't came across Stringer, you've definitely come across Go Test. Go Stringer, as I say, inputs type declarations and outputs a string implementation for the type. Really, really efficient code. Mock, which is what we're going to investigate in these next examples, is used for generating mock functions based on interfaces. So it saves you having to generate your mocks over and over again, which is really, really annoying having to do that manually. Go Test, actually, under the hood, whenever you execute Go Test, it actually packages up all your test files and outputs actually builds a main program. And the other one that people might know of as well is Hugo. It's like the code generator, static site generator for Go, which takes a bunch of files and outputs a website. So really, really good examples here of some code generators. Yes, most people here may have heard of these and may have used them, but we're going to investigate how you actually build these shortly. So code time. So we're going to take a look at mock. I assume we've all written unit tests before. You can stick Y's or N's into the chat just to say, oh yes, I have or haven't. Assume we all have, right? Because we all want to write really good code and make sure it actually works, right? So you've all probably also had to mock out something as well, you know, be it like a database or injected service or something like that. You know, you've had an interface, you need to mock that out so you can test like some sort of operation. So what we're going to do is we're going to look at basically mocking out this interface here. This is really simple. I'm the flying coder, so we're working with airplanes in code. And what we have here is an interface and the idea is this returns airplanes, doesn't take any argument apart from a context. So it's just going to return all airplanes, which are just a string at the minute. Nothing special. It's more about the generation stuff that we're interested in. But this is going to be an example of a manual one. So we then have a service. It takes the airplane reader interface, does some stuff that goes and gets them all. And some person in your company has been like, you know, some business person's like, no, we can't return 0. And if there's more than 100, you need to throw an error. So we need to test that, make sure with the logic, you know, if someone changes that it's caught, you know, very simple stuff. So what we do is we've created a manual mock interface there. So that's all right, you know, it's simple, it does the job, and you have it in your test there. You're mocking out your function and you're executing your manually generated mock. That's grand. But what if you've got like loads of different mocks or loads of different interfaces in your code and things like that, you know, and you're updating them all the time. You're gonna have to go back and remember to update all your mock functions. You're gonna break all your tests. It's gonna be really irritating to do that. So you probably want to auto generate that. So let me see. This is the auto generated version of it. So what I've done is I'm using Matt Ryer's mock package, and at the top there, it takes an output and input there. So it's going to output a thing called airplane_mock in the current repository, in the current directory, and look for an interface called airplane reader. You run that and it generates it for you. That's awesome. So I have this all set up in a Gitpod instance. So whenever I go through the code, you can actually follow along or the code as well. So I have a link and stuff here too, so you'll be able to see it shortly. And yeah, so that's exactly the same way as before. Just generate the only difference here is we've generated that mock. So it's hard to read the code on the slide, so I'm gonna just talk through it and with the actual code. The code can be found here, github.com/definecoder/go generate meetup, or in that QR code there as well. But I will share a link afterwards to the slides and stuff as well on my Twitter, which is just the flying coder as well. And the other option, if you want to open up the code with a pre-configured environment, you can follow that link, which is the same link as before, but with git.io prefix onto it. And there's a QR code there as well. So if anyone wants me to hang on to that there, let me know. I can stick it in the chat, I guess. But let's just carry on to it. So all right. So here it is here. Oh, it's timed out. Hang on. So I'm just going to use Gitpod here because it's pre-configured, it's in the browser. And this will be like everyone else can use the same environment as me if they want to. So that first example there, just to run through it quickly because we're going to get into more interesting stuff soon. We have the airplane reader interface here. You have the airplane service. You have your test with the mock. A really common thing you see people doing as well is to create like a mock. They'll have like an error mock and a mock that returns this bit of data and a mock that returns that bit of data. That gets really old really quickly. What you want to do is generate it. So if you go to the generate example, which is number 2.
Mark,
yeah.
it would be nice for people with not so high resolution screens.
Oh, yeah.
You could make this a bit larger.
Thank you. Sure. I actually had it all set up earlier. I can't remember the thing for this here to zoom in, so I'll just do this for now. There we go. Is that better? Is that okay?
That's a lot better. Thank you.
Okay, awesome. Yeah, so all it's saying is with the exact same example as before, we still have an airplane reader interface. We still have the airplane service that we want to test, and we have the test, but it's not building because we don't have the mock. So what we're going to do is we're going to put the machine to work for us by taking list command here, cding into number 2, and just running it. And you see there, airplane mock has appeared. And this is really cool because like you would never do half this stuff if you were just writing the mock yourself, because Matt Ryer's a really good developer. It's like just having him sitting beside me here and writing out mocks. So it does all sorts of things, like, you know, count the number of calls a thing is made, really well commented with examples and stuff like that. Like, who here would actually do that? And if they're generating a mock, like nobody probably, because it's just a mock. But because he's a good developer and put this together and just knows it'll run, you end up with really good code, even though it's just a mock. And you'll see here are little test runs. Happy days, all okay. So that's just an example. That's just showing like how easy it is to run, just in the command line. The next that we're going to look at is a thing called Go Generate. So this is a birthday of Go, and we're going to talk about a feature which was brought into Go in 2014 and version 1.4. So we're nearly on 1.18 very soon, a couple of months. So this is quite a while ago. Go Generate was brought in, and there's no separate install required for it. It comes as part of the Go tool, just like build, test, or vet. It's a bit like make, but for the 21st century, is how it was described. And there's two ways to basically run Go Generate. There's also a link there as well. You get that in the slides there. So you can run it in the CLI. It takes a bunch of options, build flags, things like that. Just go space generate, that easy, and it'll generate whatever thing you pointed at. The other way to run it though, it becomes way more powerful whenever you actually include it as directives in your code. What the / indicates is that it's not being run CLI, but it's in your code. Some IDEs then also let you just play the generate command for you, which is really nice. You can just go and play, or you can just at the root of your application just hit go generate / ... and it'll just execute all the generate directives that it's that are in your code. So it'll just go, like, for example, in the case of this mock, say I had like 100 mock objects and we've got the different generate lines. If I just hit go generate in the root, it'll just go and run them all, regenerate them all for you. It's really nice. And just one thing to note, actually, I don't think you can actually control the order that these directives run in. Like if you run go generate on the root, I think they just run, I don't know exactly what order it is, but I don't think you can actually control the order as far as I know anyway. Somebody can tell me I'm wrong. I usually am. So yeah, it's just showing the go generate with the little path there. So that's going to run everything that has go generate in it. It's that handy little command. So let's take a look back at our example we looked at before there. So I went and ran that in the command line. Somebody would need to know, oh, there's generated code in here. I need to go and run this in the command line. But what I've actually done instead is I've created a mock.go file in one of my examples. So I just like to keep my mock generators together in one file. A personal preference, you can keep them along with the definitions. You can put them in a file like I've done all together. So it's up to you really. And you can still run them all using go generate on the CLI. This makes it really easy to regenerate based on changes to your application whenever you use the go generate directive like this. So all you do is just in your code, add go generate. In this case, I'm using mock, so that's obviously the command, and some arguments which mock takes. Just a really simple stuff. So let's take a look at it in action. So in number 3 here, we've got go generate. Again, this is failing because we don't have the mock object yet. We have the same airplane interface, airplane reader interface there. Just return some airplanes. And we want to generate a mock from this here so we can test this amazing logic that our business people have given to us here. So I've created a mock.go. What some people will do as well is they just have the directive in where the definition is. I just put it in here for now. And it's nice because somebody coming along to your repo doesn't need to remember what the mock command is. You know, they don't need to know, oh, does this have go generate stuff in it? I don't know. They can just run go generate. And if you have these directives, it'll run. So I just run this here. Automatically, that's produced. So nice. All Matt Ryer's awesome code in there. That's just all it's done is introspected my interface here. It went and found it. It's used a thing called an AST, which we'll get to later. Parsed out this file, understood what the interface was, understood what methods and parameters and stuff it has. It's used templates to then build up this particular mock file. It's doing a lot of stuff under the hood there, but we don't have to. And if I change that interface, I can just run that again, and it'll have the updates in it as well. And let's just see if I run the test, it should pass. Awesome, it works. So this is a really good usage for generation. And that's what I use it most for, actually, is generating mock stuff, because I loathe in the test writing mock objects. It's so boring. This just does it for me, and I just have the nice little functional things to work with then to return some nice data for my tests. Dead simple stuff. Does anyone have any questions, by the way, before I carry on? Stop now, otherwise we can just take questions at the end. All good. Happy days. So now we're going to build a generator. Just checking time, 20 minutes, I think. We're going to build two, actually. We're going to build our own mock generator, just to sort of go through some of the steps which go into actually producing a generation tool in Go. As I mentioned earlier, a generator is simply a CLI with a main, main entry point and some way of taking input. In this case, it'll be command line flags we'll be using. Talk through the code and we'll see it running as well. But before we start, there's a few packages which you're really hard to escape from whenever you start doing this sort of stuff. Generation, it's usually based off types or input or modifying or investigating code. So you'll need to know some of these packages here. You'll come across them. You don't need to know them inside out, like I certainly don't. I usually find myself jumping back into the docs again if I want to use them, sort of thing. I know it whenever I'm using it, then I carry on. There are some tools though which help sort of piece some of these things together, especially the abstract syntax trees that we'll get to as well. It's basically the structure of your code. It takes all the grammar, all your tokens, all your syntax basically, and builds them into a big node tree structure. So for me, like, I found it was just a bit of trial and error whenever I was getting started with this stuff. I never really went this deep down into it before I did this Go generate stuff. So it's really cool. But yeah, so the first ones are Go types, which gives you your structs and interface information. AST, which gives you all your tokens and types for a file or group of files. And you've got Go token, which is your individual tokens. And you can load them using Go packages.load. There's a few helper packages in there as well, like stutil, I think, is one, which lets you, like, give you some little helpers and stuff around them too. So this is what an abstract syntax tree looks like, isn't it? Just beautiful. Get your code. It's then your code is split into statements, declarations, variables, all sorts of stuff, assignments, all the way down until you hit the end of a file. And it's basically how Go basically sees your program. So AST is heavily used as well as generators, but also for linters and static checks like GoVet and Go imports and everything all use AST, because it allows you to basically query your code. Like, for example, you could see, like, how many times is this type used in this particular package, or how many packages are being used in these files. You can then use it to go and inspect things like, okay, are you using print lines in your code? You could write a linter for that using the AST to go and interrogate the files. But you can also use it as well to modify and manipulate code too. There's a really good tutorial from Just for Funk on AST using Go parser as well. I'd recommend going to have a look at that before you do start sort of diving into this sort of stuff, if you do feel that way inclined. Again, these slides, I'll share these slides. You can get these links and stuff after. I have a resources slide at the end with all the links on it too, because I'm not kind. So there's an online abstract syntax tree viewer as well. So what we're going to do is we're going to have a quick look at it. Is someone going to talk there, by the way? I think someone unmuted. No. Oh, let's see if there's a question coming. That's all right. So let's take a look at the AST viewer first of all. See what we're actually dealing with here. So this link is where it is in the slides. This is just a little very simple example program it gives you. This is just an online viewer. If you hit parse, what that will actually do is that will expand out the abstract syntax tree for that particular bit of code. You fully dumps it there, and you also get this little like nodes, like viewer thing here too. I find this really invaluable whenever I was working on generations and stuff like that, because it lets you, like, for example, if I wanted to add this line, say I want to duplicate that line there, for example, I want to say like Hello Berlin or something like that, like here. Oh, I can parse that. Then I can come down and actually see, right, well, what is that I actually need to add in here to be able to do this? You can go down, right, Hello Berlin. So you can see, right, that's a AST basic literal. It's underneath the call expression, which is within a statement. So then a statement itself is within a block statement, which is what all this is. This is mad. Like, I really, whenever you're doing this here, it's really handy to use like an AST viewer like this if you are manipulating code and wanting to add things into the code and things like that. Really, really useful whenever you're coming to generation. I'll not go into too much detail here, but just know that this tool is there and you can use it to introspect like programs, and that you see where you might need to inject into the node something or modify something in the abstract syntax tree. So that's that little tool. Really useful. You'll see it later on. We'll actually use it. So yes, this is what we looked at before there, just a snapshot of parsing a file. We've already looked at that on the website. So what we want for our generator is to produce a really simple mock when given an interface. It won't do any error checking. It won't be very smart or pretty. It won't be nothing like Matt Ryers. It won't be as good as that. But it's just to show some key concepts that you'll need whenever you're working with Go packages and types, and also how you go about actually generating the code and producing it. So again, same old interface as before, the good old airplane reader that returns us some airplanes. And what we do here is we start off with a main.go file. Most generators, including this one, takes input, and this one's taking input in the form of command flags, and it supports two commands, two flags, type name and output. So type is the name of the type to generate the mock for, and output is the name of the output file. Pretty straightforward. Output, output's actually optional as well. So yeah, I say a good rule in coding is to fail fast. So if we don't have a type name, just fail straight away. So that's the easy part, getting our information in. Then it gets interesting. So first thing we do is load the package information by calling packages.load up at the top there. Okay, this takes a packages.config, and you can tell it what you want to include in that. So for this to work, I need to get the types, I need to get the syntax, I need to get dependencies, I need to get imports. Dependencies is needed because in my case, we're using context, which is classed as a dependency. If you miss out this here and you have something that's not in like real standard library, like a real just literal like base part of the language, you'll get a invalid type argument whenever it comes to it. So there is a directory that you're looking into. So that's just the current directory in this case, and we're just looking for all file types. So we can take a pattern for files as well. Obviously we fill then if the package length is 0, and we are looking at further down. Then we have object being assigned from package type scope lookup type name. So we are just looking at the first package here, which is 0, because we only have one, because I know that because it's in main. And that's the only package that we're looking in. If you had multiple packages, say for example, you're traversing directories in this, you'd probably have to iterate those. But in this case, we're just looking at the first package, which is main. We then get the types, the scope, and then we look up the particular type name. So that's the type name we've injected in our flags. In this case, it'll be airplane reader. And if it's not an interface, we then fail because we only want this to work with interfaces. And then we convert the object to an interface itself. And what this is actually used for is to actually then inspect the interface to get its properties, their names, their parameters, and their returns, which we'll see next. Did I skip a thing there? Oh no, I was just going to this here just to show, just to take a wee bit of a step away from that horrible code. The other really useful thing in Go is Go templates. Has everyone used templates? Like, I assume most people are familiar with them anyway. So basically, like sort of like handlebars or Angular and Vue templates and things like that. Go has template and language as well. And they're really useful in code generation. Pretty much all code generators in Go use templates because it's a lot easier to read a template than it is a string, like a big concatenated string or whatever. And it's also a lot easier to just add this new file than it is to build an abstract syntax tree and add that in. Like we're just creating a brand new file here, so we're not manipulating any existing code. So in that case, just use a template. It's a lot easier. You could build up a string, with format or string builder or whatever, but this is easier to read in my opinion. So as you can see here, we've got a set of variables that we're using in this package, in this little template. We're going to use these to replace pieces of text in the template to create an output file. And as well as that, we're iterating over a variable called methods. And this is actually an array that we build up from interrogating the interface. And within the loop, we then build up functions using the parameters and returns and things like that we've parsed out of the interface from the previous bit of code. And we do the same for the second loop down at the bottom here as well. Iterate that methods and then build out the function. So you can see there, type name, params, returns, and then we return mock.name func param name. So that's actually a function and stuff like that that is generating, and we'll see it in the end. But this is how you basically start off with generation. This is a really simple way to do it as well. Like you could just write a template that just does something, just inject your name in and you've generated code. Perfect. But this is just taking it a little bit further. So main.go is now continued. So now that we have our main information, we have our type. We then can enumerate that type by going interface.num methods and then just iterating that. So we've defined a struct called obj up here at the top. It takes package name, type name, and methods. I've defined a method type as well. So to get method info, you need to call them by index. So by interface method and then index. So that's why we iterate the number. That's why we check for the number of methods, because that will then return. In this case, there's one method, so you'll get one there, and we'll get method at index 0. And what we then do is we then interrogate that to get a signature, to get its types, its returns, all that sort of good stuff. All this code will be available. I'll not go into too much detail here, but just know this is some code here which you can use to inspect a interface and get its types and stuff like that. Next, what we do is we then compile the text template and execute it with our object from before that contains all the method information. So that obj that we had before, we just pass it into the template. I've actually updated this example since then to use go embed. This is just reading the file back whenever I did this originally. Just execute the template. And then the last thing to do is to run format.source, which basically runs GoFint. So your code looks nice at the end of it. That's a nice thing to always do at the end. If you're generating code, make sure you do format source as well. And the rest of the file that's in there just deals with saving the output. So let's take a quick look at the actual code and run the generator instead of looking at on slides. So this is under example 4, simple mock gen. And let's start off with our airplane here. That's our same reader as before, exactly the same. We've added the go generate directive, where this is what I have actually already done go install on this, so it's ready to go, so we're not faffing about with things. And this is taking the type airplane reader. So that's just our CLI argument that we saw before, just here. That's all it is. And you can look through this code yourself. I'll say I'll have links and stuff for this here, but you can run through this code. It's as lovely as it looks. It can get quite complicated, some of the stuff, basically, and if you're looking through it. But needs must, and it's good to play with this stuff every now and again. And finally, let's look at the template as well. So the templates really are the core of code generation. Pretty much everything uses it. So nice to read and stuff as well. Really easy to read. And what we'll do then is we will run our generator, and there's also readmes in all these examples as well, just explaining things too. And what we'll do is we'll just run this run go generate. Hey, it worked. And there we go. So you can sort of see there's the template there. Let's just take that, stick it into here. You can basically see how that marries up. There's the package name has been injected. The type name has been injected with a mock suffix, all the methods, and same below. That's really sweet. That's really cool. Any questions on that stuff before we move on to the last thing? You know, if we've got 10 minutes left, I think. All good?
No, that's all good. That's really cool.
Cool, yeah, sweet. Yeah, I mean, this is only really getting started. Like, you can do so much more with this stuff. Like, I don't really have time to go into a lot of it, but abstract syntax trees are a whole talk on themselves. They break my brain every time I use them. So, bit of a recap then. We've looked at Go types, syntax trees, Go tokens, and they're the building blocks of Go code. You can interrogate and understand code using the ASTs. Go generators are really just CLIs with a main that takes some arguments. That's all they are. And you can hook any main file up to Go generate. Any executable can run in Go generate, like, you know, not just Go code, any executable. And you can use text templates to keep your code neat and improves the readability of the desired code output. But what sort of rough rule I have with them is if you need to interrogate existing code or modify existing code, I tend to use AST for it, the abstract syntax tree. You could possibly wangle some awful regex to do something, maybe just one off. But the nice way to do it is with abstract syntax trees. We'll see that next, where I actually go and inject code into 2 different files. And templates I generally use to create the new code, whether it's a new file or say appending a block of code into an already existing file. But I would never use template to modify an existing function or something like that. ASTs is what you would use for that generally. That's a rule I've discovered anyway. Someone might have a different idea. So now we're on to our final example, and hopefully this is like giving people some ideas as well of what they could do. Maybe in work, there's like you're having to keep on writing this boilerplate code and thinking, well, I must see a way to automate this. You know, maybe like you haven't maybe dipped into ASTs and the parsing of tokens and stuff like that in Go. Like I really want this to sort of just give people some ideas and think, actually, I can do this. It looks really cool. I'm going to automate our API HTTP handlers or something like that. Yeah. So the final example is just basically that. It's auto-written a API top to bottom. So we're going to generate from the HTTP handler down to the database layer. It's just a really simple database. It's an in-memory data store. It uses domain-driven design, so bounded contexts and things like that. So whenever you're building APIs, what I find anyways, there's an awful lot of bootstrap code to spool up a service, add endpoints, especially for larger projects. You might have various middlewares that go in. You might have metrics that need to be captured, error handling. You might have Swagger docs that you need to add in. You might have, I don't know what else, you know, all sorts of stuff, validations need to happen, all this bootstrap stuff. It's really boring to do. You have to do it over and over again, and it's easy to forget about it too. So all this boring crap can be generated. So let's go and have a look. Let's go and generate an API. So here's where the code can be found, or it can also be found on Gitpod as well. And you can use this as the basis for your own API generators. You would need to change this. It's not, I wouldn't call it production ready by any means. There's a few bugs in it, but it's okay, it's getting there. So down to number 5. So what we have here is another airplane service. This is broken into a few different things. We have at the very root of it, we have a routes thing. We already have one generated API here as well called airplanes. This is our airplanes domain. It has a definition of airplane stuff, has an airplane struct, has an airplane service where you can get airplanes, and also you can now add airplanes as well. And it returns a proper airplane struct now, not just a string. You have your readers, you have your writer, and you have your reader-writer. That's just why I generally do my services. I generally have like the data store split into a reader and a writer. Means that what I can do is actually create like a facade layer on top of the writer and like have like, or on top of the reader and have like caches and stuff like that. And all the service needs to see is just this one interface, doesn't know anything different. So that's our template for our thing. We then have an HTTP handler, just using the standard library HTTP handler. So it handles a get, handles a post, goes and does some stuff. And all this is all auto-generated. I haven't written any of this code. It's all auto-generated. We have a service layer, which does some stuff. I say it has a to-do there for additional logic. Got a way of actually doing this better now, I think, as well, where you don't have, we can actually regenerate all this here and throw it away after, but well, that's for another time. And the airplane create, where you go and create your airplane. We inject in our interfaces, and what implements our reader and writer is a in-memory store. Just for the purposes of this demo, really simple in-memory store, but this could be like a SQL store. You could auto-generate your SQL, and you could do all sorts of stuff like with this stuff. Well, it's all open. So yeah, again, all it does is reads airplanes from this little array. There's no like type safety, there's no like concurrency safety or anything in this here. It also adds them. Man, it's really bad. Don't use this code. This is an example of a code you wouldn't want to use, probably. You don't want to have that probably for vtext and stuff, at the very least. Anyway, I'm rambling. So let's run this here. So to run this, what we'll do is we will do cd, see if it actually works. Actually, let's see if it works. The API, do cd command API. Go run the hopefully that runs. Yeah, it's running. Happy days. And let's start the terminal. Go over here. And let's get our airplanes. Post. Run airplanes, I think it is. Demo thing. What? Don't tell me it's not installed, stupid thing. Hang on. Being stupid. I want to get back to print it out nicely. I don't know if JQ installed this, so I'll just use that. Anyway, while that's running, what we're going to do after this is we're going to then add our own new domain in and see how that works. And then we'll go through the code and get to see some lovely abstract syntax trees, and then we'll be done. Hopefully it won't be too long. Come on, hurry up.
Not a car user then, it seems.
Yeah, no, I did have it set up on this. I don't know why it's not finding it. It was set up on it. It's worked every other time, that HTTP thing. It's nice because it gives you like the nice output and stuff. I could install JQ. It probably would have been quicker actually in hindsight. Oh well. Give it a second. Just auto-generating some code here.
So we have code generation and
yeah,
code
generation
in the background here.
Yeah, that's it exactly. So hopefully that works now. Yeah, it does. So that's it in our endpoint there. That's our live endpoint. If we get and it returns in an airplanes, that's all we have now. If I do, there's one, it takes a property of name, we'll call it Berlin. We're going to add a new airplane called Berlin, and that takes in as an HTTP post. So cool, that's there, and get all our airplanes to test in Berlin. Okay, let's now check another one. So what we're going to do is we're going to add a Berlin endpoint in. Let's just make sure it doesn't exist. I'm not cheating. There's a 404. Okay. What I'm going to do is I'm going to run the generator here. So if I exit this here, if I cd 05 API gen, if I go cd command gen, so under here is where the generator lives. There's a bunch of templates for each of the different files you saw there corresponds to one template. So you've got your HTTP layer, you've got your service layer, your memory store. And I think like from memory, all this is using is like 3 or 4 variables. That's all this is taken, and it can produce all that code. In the main as well, in the README, I have the thing for, yes, there it is there. Go run domain. So I'll call this Berlin and keep the eye up here under 05. Domain Berlin. There's all the output there. So it's creating domain, creating HTTP, creating memory store, and we have our Berlins. So I've decided that your root things should all be pluralized. So they're pluralized. So we have, instead of a Berlin, we have Berlins. And this is all auto-generated. It's generated your definition. So it all just gives you 2 things to start off with, and you can go and fill this in with whatever. Another way of doing this is you could actually create a generator where you define your struct and then run a generator using that struct. And that's how you can actually go about generating your SQL automatically, because all your properties will be there. And it's generated your services, your readers, all that sort of stuff, generated your HTTP endpoints, your data store, and your service. So let's see what happens now. If I call Berlin's, let's stop it. Oh, one other thing it's done. That's the code it's used with the templates. It's used abstract syntax trees to inject into this here some constants for your endpoint URLs. So that's done using AST. And it's also done something else in your API main. You have to wire up your HTTP handler. So that's done there. So it's added all this for us, including the dependency injection and everything. Really sick, like really cool. And let's see if it works. So let's run that again. Please work. Please work. And if I do our Berlin, no. Where's the HTTP? Berlin's. Hey, we've got a Berlin. It's just called test, because that's just a test data which gets added in. But I can add a new Berlin. So silly calling it Berlin. I'll add a new Berlin. And that's like so quick. Like, how long would this take to do if you were coding this out yourself? You know, that'll be so boring to do. We'll call it Berlin Go. Let's get them all. Berlin Go. Perfect. So now as a developer, I can now just spend time focusing on the interesting stuff, right? What's the business logic for this here that I need to add in here? What sort of validation do I need to do? And add in your business logic, you know, but you could also have a lot of that automated too. Like if you published a Kafka, you can publish the Kafka and all the rest of it. Let's get to the interesting stuff here quickly, because I'm really running out of time. I spent too long, as always. Okay, so this is a really good reference point to start off with if you're wanting to do this sort of stuff and produce APIs and things like that with Go. I'll run through it really quickly. What you do first of all is you do all the template stuff that we saw before. All I do is in the CLI input is take your domain, and that's basically it. All it does is then takes a lowercase, gets a title case, and gets a date as well. So it can generate a little message saying, here's code's auto-generated. It then goes and generates all those template files from those like 3 arguments, produces all those. Then after that, we then have some abstract syntax tree stuff to do. So what we do is we use token file set, and that's really where what you do is you parse your file. As you can see here, we're saying, right, parse roots into file set. File set just holds the tokens for you, and say, all right, I want to include errors as well. What you then do then is you run through the declarations for that. That won't make a lot of sense right now, but basically what the file is the file with one declaration, which is a constant. And what I'm doing there is I'm iterating those constants to see, do we already have one there named Berlin's, for example, in this case? So if you already has the constant, it doesn't add it. Otherwise, what it does is it adds the constant in, which is a basic literal of a string, builds a domain string. As you can see here, it does this. It does that stuff there. And then it adds it as a value spec as well, so that value gets added in. And let's just take a quick wee look at that. Let's just bounce that in really, really quickly into this little tool. I say this tool is so useful for just interrogating things. Oops, parse. And you can see here exactly how it is. That's basically how I wrote that. Was I went into this here, put the bit of code in that I wanted to have output, and figure out, right, what is it actually built using? Right, it's using constants, using AST object, ident, etc. So that's how I wrote that. And back to here, we basically just then append that into these into the nodes, sort it then. So I actually sort this here so that it's actually alphabetical order after, because you can sort them. And then I do a format. The other thing I do then, the second bit of AST is on the main, where we add in that WAP. This is where look at this lovely bit of code here. Isn't that just beautiful? That's horrible to read, and it's not great to write either. but it does really powerful stuff. I can inject in code safely into the tree there. So what I did was I basically loaded this in to that little file set thing. I found the main. I then essentially each one of these here is a node in the abstract syntax tree. I then just created this node and then just added the node, just as you do with any other like slice, just add it into the node. And then once you save that, then you get your code. And you can see here, like there's new HTTP handler, new Berlin service, new memory store, things like that. It all matches up with what's in there. New Berlin service, new memory store. You've got all this stuff, and that's how you use an abstract syntax tree. It just build it up with the nodes, and then finally what you do is you append it to the existing list of nodes, and that's it. Then you format and save it. Always format and save, so that'll then make it go fint for you. And that is basically it. Now, this is, I say, the talk was just a dip in the AST. You can really do a whole talk on AST, like, but I just want to show what it is, how it can be used, just as a brief overview, so that if you do decide I want to do this sort of thing, here's a bit of reference code you can use and go from there, really. And that is basically it. So here I've generated an entire thing, and Jad, who's leads my team, I won't tell him that I've auto-generated all this code. I'll just take like a day. It's like, oh, I'm working away on this, generating this Berlin thing. He doesn't need to know. Don't tell him. Don't tell him. And that's the end of the code examples. That's the end of the code examples. So just to recap, about 5 minutes over here, so I'll just wrap up. So we've seen how we can generate endpoints for an API service, and we saw it working. It actually did work. I can save an awful lot of time. You're bootstrapping new features or endpoints. You could really bootstrap a whole microservice if you wanted to. As generate, you can guarantee consistency and company Go best practices. So like I had everything was commented there for me. I said everything had to be pluralized, and my services had to look a certain way, and I use readers and writers and things like that. That's all codified in there. But just be careful, so any errors that you write will also be coded in there too. We saw how we can use the abstract syntax tree to not only read code, but also create it, check constants, add constants, add it to the code and things like that. And we used that tool to help us write the AST stuff too. And that's basically it. That is me done. There's a list of resources here that I used. Really good one, which inspired me to do this talk, was the GopherCon UK talk in 2019. It was really good. I say Just for Funk have a brilliant video on this stuff, and he also has a good blog on it too. And yeah, there's people a lot smarter than me have done much better talks than this one, but that's something I put together there just to sort of hope fire people up and say, right, I'm going to do some cool things with generation. I'm going to let the machine do the work for me. And that's it. So I say you can find me at the Fine Coder. Why has that got an E? I don't have an E in it. It's Fine Coder like this. I think Austin I don't know why I've done that. But anyway, that's me. GitHub.com/theFineCoder, or Twitter, the Fine Coder without an E. That's me. Any questions?
That was fascinating. Yeah.
Yeah. Okay.
It looks like you basically got half of Rails in a few templates.
Yeah, basically, like yeah, that's essentially it. Yeah, I mean, you can do a bunch of stuff. Like I came from C# before this, so they had T4 templates and C# and stuff as well.
So have you taken it further? Like, have you actually got to the point where it's sort of, I suppose, generating more of the same, like more?
Yeah.
Yeah. When you're spinning up a new API, you're literally just, Rails generate API.
Yeah, basically, like now in N-Chain, I haven't got that far. I've actually been so busy doing so much blockchain stuff and libraries. But in my last company, Teamwork, yeah, and we had a product called Spaces that I worked on, and yeah, you could just bootstrap the whole API top to bottom with one command, and you just went. Then all you did was go in, fill in all the blanks, add in the business logic and stuff. It was really effective. It saved so much time. And I was able to code in, like I want to have like a maximum of 3 arguments in a signature, wanted to enforce naming, all sorts of stuff. It was really good.
Cool. Thanks. That's really useful. Yeah.
Yeah, no worries.
Anytime I've seen AST used before was on ES Build. I don't know if you've heard of it, but yeah, basically a Webpack replacement written in Go. And yeah, super quick. It's awesome. And you can actually call it from inside Go. So I basically wrote a web server that then compiled its own JavaScript, and yeah, it was awesome. But yeah, he's the guy who wrote that. God, Jesus, he took JavaScript apart using AST and put it back together. So yeah,
that's brilliant. Yeah, it's a perfect use case for it as well. Yeah.
Yeah, I mean, if you really want to generate APIs and work more on that, there is a kind of a product from Mark Bates, right?
There is, yeah. Buffalo, isn't it?
The whole Buffalo framework. It is kind of Ruby rewrite and go, right?
Yeah, that's right.
Do all these generations and so on, and he has version 2 out now, and so on. But just be careful. You might have to debug all this generated code one day. So maybe don't open it, right?
That's right. Approach it with caution. You know, the way I generally do it is I write the code that I want, and then I go and create the template from that, and then add in the parameters. So generally the way I do it. But yeah, I know you're right. Buffalo uses.
It's that whole thing with Rails that if you're writing Basecamp, then it's perfect. If you're writing anything else, then sooner or later you're going to have to you're going to bump into the fact that basically Rails was designed to write Basecamp, and so for any generated code, like you always end up in the same situation. Taking somebody else's generated code and generating your code from that is never going to work for your use case because you have a different use case. So,
exactly, yeah. Because everyone. You know, if you're using Buffalo or whatever, it works for you, perfect. But usually what happens is people have their own thing, needs to work a certain way, and so they can codify and generate their own stuff. Yeah, exactly.
We got one question from the chat. So the advantage of using an AST to generate code compared to a template, the Go templates.
Oh, the reason I generally wouldn't use AST to generate all the code. I use it to modify existing code. So I would totally use a template engine to generate most of the code. Where AST comes in for this particular example anyway, where it comes in for me is modifying that code which is already there. So I was injecting in constants and I was modifying the existing main function. That's where it becomes kind of useful. I've never used Jinja, I don't know what that is. But if maybe it's something which abstracts away the AST and makes it easier to write, I'm not sure. But yeah,
I think it's a template engine from the JavaScript world or something.
Oh, right, okay, fair enough. It's kind of like Go template then, basically, like text templates and Go. Yeah. Well, that's where I separate them. And this text template is I would use the template to write the new code, and then I use AST to insert or modify existing code. That's what I did anyway. Whether it's the right thing to do, I'm not sure, but that's what I did.
Yeah, there was actually an earlier question in the chat. How does mock differ from GoMock? Any additional features?
I really like mock because it's so simple. I used GoMock a long time ago and I didn't really like it. What I like about Matt Ryer's mock is that it's just functions. So it implements your interface, and all you do to actually use it is you just implement the function. It's so easy to use. Like I'll show you here. If I go back to the code, I just like it because of its pure simplicity. Where is it? Here's an example of it. So like here, you just work with functions. So I find that so much easier than having to have like, what way do those ones work? You always have to set up like your properties that come in and your expects and stuff that come out and things like that normally, whereas this here is just a function. So it's so simple to use. Like I can handle, like, so if I had a property in here, like I can handle that property and like if the property is this here, do this, that, and the other, or return an error or something. It's so simple. I just like its simplicity, that's all. It's for me, it's the one which clicked with my head better than any of the other ones in Go so far, like Go Convey and stuff as well. It just worked better for me.
Okay.
And it's has the auto generator, so even better.
Cool.
Any more questions?
I could add one myself. I'm working with AST, sometimes with another project too, and I'm often using the Golang.org xtools Go packages
Yeah,
package.
I'm using
which
that too.
kind of is a wrapper around the core packages that you showed us.
Are you talking about this like this one?
Yeah,
Yeah, that's a,
yeah, kind of. I think
Yeah.
that next to the Go AST and AST util, there's packages.
yeah, there's
also.
packages too, which is it's really nice actually. I used it in the previous example actually. I think I'm pretty sure. Yeah, that one.
Yeah, I see. Yeah, cool.
Yeah,
Right.
yeah, it's really nice. Yeah, for reading package information and stuff. Yeah, that's great. Where am I using it here? Actually, I'm pretty sure it's just to read the main. Where is it? I'll still highlighting it for me, but yeah, I'm using it too. Yeah, it's here where you do packages.load. Yeah, that's where I was using it there. So it gives you the package information and also type and syntax and stuff for it. Really handy. And yeah, AST util is really good as well, but it never sits right with me that it's under X because like obviously that can change or go at any time. It's like, oh, yeah, just proceed with caution there.
The slightly scary part of it, yeah.
Yeah, absolutely. So like, yeah, just be careful using those
But
packages.
even those extended standard library parts are more stable than the standard library, the real standard library in other languages. So it's
Very true. Very true, man. Yeah, that's a good point. Very true. Yeah, it's
so
handy. It's some nice things in it, like for some helpers in it for like just adding it's for adding the imports. I think I've used it for adding imports and stuff. Really, really nice. But yeah, all this code sitting there if anyone wants to take it and tear it apart in their own time. I'll share the links up on my Twitter too.
cool. Any other questions? Doesn't seem like it.
I've got a use case for it at my current job, possibly. Since
Cool.
we convert types quite a lot. So from the API level to the business layer and back, and from the business layer to the database layer and back.
Oh, that's a
And
perfect case for it. Actually, I do the same myself, and
perfect, yeah.
I'm doing the same thing too. And it's really boring code. I should, yeah, auto generator for that's perfect. Yeah,
good. Yeah, I think so too.
yeah, it's a good idea.
Okay.
So yeah, have fun doing it. I really enjoy writing it. Like, it's cool stuff. I've gotten a whole idea for this thing that I'm going to write, and we'll see if it works or not. But we'll see. Maybe be a talk in a year's time. We'll see. Either that or just disappear in nothing. We'll see.
Yeah. Thank you, Mark. Thank you very much.
You're welcome. Thanks for having me.